page of this booklet is just going over plot points. You guys already know how to do that, so I've already got it done. Can I fit all this on here at the same time? No, but either way, you guys, there's the answers to 1. There's the answers to 2 at the bottom. Okay, you guys can pause that and go back or whatever if you need to look at that. Okay, graphing relations. Okay, and what we need to talk about here is linear relations. So notice, for a linear relation, the points lie on a straight line. So notice, if I were to put down my ruler here, all of these points are in a straight line. Notice, a linear relation does not mean that we draw in the straight line. In this case, these are the only points in this relation. These are the only XY combination, input-output combinations in this relation. There is no 1.1 for n. There is no 1.05 for n or whatever. It's only 1, and 1n is 1. The output is 3, so we get the 0.13. Nothing in between. Okay, another way we can tell if something's a linear relation is if the change in input is constant. Notice this is always going up by 1, and notice these are always going up by 2. So if we have a consistent pattern like that, that's another way to tell that it's a linear relation without even graphing it. Okay, so let's have a look at an example of this at the bottom of the page. So first it wants us to graph this. So we've got the 0.02, got the 0.15. Obviously 5 is halfway between 4 and 6. 2.8 and 3.11. This guy's a little bit low. Okay, so is this a linear relation? Well, are the points in a straight line? Yep. So yes. Points in a straight line. Okay, and notice the other way we can tell is that if we look at this input, it's going up by 1 every time. And the output is going up by 3 every time. Okay, so the other way we can tell that it's a linear relation is that I'm going to write this up here. Change in table is constant. One other thing I want to point out real quick on this one is we can actually see the change in the table on the graph. You notice up here they showed us that the input's going up by 1 and the output's going up by 2. So between points, this is the input going up by 1, that's the output going up by 2. So we can see the same thing on the bottom graph here. From this point to this point, we're going right 1, which is the input going up by 1. And we're going up 3 here. So because on our table the input's going up by 1 and the output's going up by 3, the same thing happens on our graph. Here the input went up by 1 and the output went up by 3. Okay, and now as practice we want to write an equation using x for input and y for output for the table above. Okay, so all of these are going to be, notice we'd always have independent dependent here, so it's going to be x and y. So our equation is going to be y equals, and we know our y has to go up 3 times as fast as our x, so it's going to be 3x, and then we're going to have to add or subtract something here. So if x equals 2, or sorry, if x equals 0, then we'd have 3 times 0 is 0, but we want it to be 2. So I'm going to add a 2 onto that. And let's just double check it with 1. If x equals 1, I get 1 times 3 is 3, plus 2 is 5, so that works good. So there's our equation. Okay, here we go, next page. DVD Club. So you can buy DVDs at a reduced price according to the table of values below here. So if you buy one DVD, it's 20 bucks. 2 DVDs, it's 25 bucks. So basically, it's like that Pizza Hut regular price, $5, $5 thing. Okay, and we remember that this side is always going to be independent. So obviously, we're going to choose how many DVDs we're going to purchase, and then the cost is going to depend on how many DVDs. Okay, when you're doing a graph, it's always dependent on the left, independent on the bottom. Oops, you guys see that? There we go, I'll squeeze that in there. Yeah, so it's always dependent on the left, independent on the bottom. Okay, so let's do the independent along the bottom first. That's 1 through 4. So first thing we want to do is we want to label this down here. So this is going to be number of DVDs down here, because that's our independent variable. And we always want to start at 0. And then we want to figure out, fitting the numbers in between 0 and 4, we want to fill up as much of this as we can. Because the whole point of a graph is to show people what's going on with the numbers without them having to look at the numbers. If we've got like 1, 2, 3, 4 just stopping here, then our graph is only going to be like that big, and it's not really going to show people the information very well. So we want to spread it out as much as possible. So let's try maybe 4 spaces between 0 and 1. So that would be 1 would be there, 2, 3, 4 is not going to fit. So 4 spaces isn't going to work, so 3 will for sure. So let's use that then. 1 is there, 2 is there, 3 is there, 4 is there. Okay, perfect. Okay, so that's that part done. Now we need to do the cost on the left side. So I'm just going to turn my page here, right? Cost in dollars. When you're writing these labels on, make sure you leave enough space that you can actually fit the numbers in here, same as I did down here. I wrote my number of DVDs a bit lower so I could fit the numbers in. Okay, and this time we want to go from 0 to 35. Okay, and basically you just want to guess and check and play around with this. I've done this question tons of times with different classes, so I know that the best way to do this is have each 2 spaces be $5. So that's going to be $5, that's going to be 10, that's going to be 15, it's going to be 20, 25, 30, and 35. Okay, perfect. The other thing we want to do with this graph is give it a title. I recommend doing the actual points on the graph last, because once you put the points on, you feel like you're done. So let's put the title on before the points. In this case, the graph is about the cost of DVDs at this club, so I'm just going to write cost of DVDs. So now when people look at this, they're going to know what the graph is about. Okay, perfect. So we know 1 DVD is $20, so that's there. 2 DVDs, $5 more, $25. 3 DVDs, $30, and 4 DVDs, $35. There we go. Okay, B. Should the points be joined? Okay, so should I take my ruler and draw a line through these points? Okay, well, you guys remember that if I were to draw a line between these 2 points, it would mean that we're drawing that line instead of drawing in all the infinite little decimal points in between, right? So for example, you know, there might be a point at 1.5 DVDs for $22.50. Okay, so can I buy 1.5 DVDs for $22.50? No, I can't buy half a DVD, so I shouldn't have a point here at 1.5 $22.50, and obviously I shouldn't have any of the other parts of a DVD points either. So should the points be joined? No. Why not? Well, we can't buy half a DVD. Can't buy part of a DVD. So because we can't buy part of a DVD, we're not going to join the points. Okay, C, is the relation linear? So this is different than whether or not we draw the line. So are the points in a line? Yes. So is the relation linear? Yes. Points in a line. So notice, oops, just wrote that down. Yes, points in a line. So notice, this is, you guys can get really screwed up on this. Whether or not you draw the line depends on whether or not there's infinite points between these 2 points, and whether or not it's linear is whether or not it's in a straight line. So really important to keep that straight. Okay, and let's have a look at the pattern in the table now as well, just to double check. So these are all going up by 1. And over here, the cost of the DVDs, those are all going up by 5 every time. So another reason we know it's linear is the table change is constant. You can also write this down. Oops. And I can't write the word table. Table change is constant. So that's the 2 ways we can show that or see that the relation is linear. That the points are in a line and the table change is constant. Okay, describe the patterns in the table. How are these patterns shown on the graph? Okay, well, we already looked at the pattern in the table. The DVDs are going up by 1, and the cost is going up by 5. So DVDs up by 1, cost up by 5. Okay, and let's have a look here now between the points. So we always want to look at what's happening horizontally and what's happening vertically. So between here and here, it's 3 spaces on the graph, but it's actually 1 DVD if we look down here. From here to here is just 1 DVD. So even though it's 3 spaces on the graph, that's like, oops, it's just going up by 1. I don't know why I wrote 5. Probably getting ahead of myself thinking about the next one. Okay, and then from here to here, it's going from 20 to 25, so that's going plus 5. So what's the pattern on the graph? And it happens every time we go right 1, up 5, right 1, up 5. So because DVDs are going up by 1, on the graph, we go right 1. And then because the cost is going up by 5, we go up 5. So that's the pattern on the graph. Okay, and now they want us to write an equation from the table. And notice on the table, they've already given us variables. They've given us the cost is capital C, and number of DVDs is small n. You remember when we write these equations, it's always dependent variable equals something with the independent variable. And you know what? I'm going to scratch out this A here, and I'm just going to do E up here so we can talk about the table and the answer at the same time. So it's going to be the dependent variable C equals, and then something with n. Well, because these are plus 5 and these are plus 1, the cost is going up 5 times faster than the number of DVDs. So it's going to be 5n. And then our adjustment, if n is 1, cost would be 5. But we don't want it to be 5, we want it to be 20. So I'm going to add 15 there. And let's just test it with 2. So if n equals 2, 5 times 2 is 10, plus 15 is 25. It works. That's 25. Okay, and one more page. This time we're going to graph a linear relation from an equation. So here we've got x equals -2. 5 minus -2 is the same as 5 plus 2, so that's going to be 7. 5 minus -1 is the same as 5 plus 1, so that's going to be 6. 5 minus 0 is just itself. 5 minus 1 is 4, and 5 minus 2 is 3. Okay, so let's put those points on the graph. So I've got negative 2, 7, negative 1, 6, 0, 5, 1, 4, 2, 3. Okay, should we join the points this time? Okay, so you remember, whether or not we join the points, whether or not we draw the straight line in, depends on whether or not we have decimal points, all these little infinite decimal solutions in between here. So is it possible to have, for example, 0.5 and 4.5? Yeah. Yeah, because they're not DVDs. If I put in x equals 0.5 up here, I'd have 5 minus 0.5 is 4.5. That totally works. And that goes for all of the other little decimal solutions in there. So we need to represent all those little decimal solutions by drawing in a straight line. There we go. And we put the arrows on the end to show that it keeps going forever. So should we join the points? Yes. Infinite decimal solutions between the points. Yes, we've got infinite decimal solutions between the points. Okay, C wants us to describe the patterns in the graph and the table. Okay, let's have a look at the table here. So that's going up by 1 every time. And these are going down by 1 every time. -1, -1, -1, -1. So between these points, between that point, let's just push the graph up here, and between this point and this point, it's tough to see here because it's so small, but that's going +1. My x is going from -2 to -1, so that's +1. And my y is going from 7 down to 6, so that's -1. So the pattern in the table is x gets up, basically we add 1 every time. And y we're subtracting 1 every time. And on the graph, that means between points we're going right 1 and down 1. Okay, and the final question, is the relation linear? And remember, this has nothing to do with whether or not we drew in a straight line with a ruler. Is it linear? So, do we have constant change in the table? Yes. This goes up by 1, that goes down by 1 every time. And are our points in a straight line? Yes. So is this linear? Yes. 2 reasons. The table change is constant. And the other reason is that the points are in a straight line. Oops, and you guys can't see what I wrote down there. So is the relation linear? Yes, table change is constant, and the points are in a straight line. Okay, you should be able to do your assignment now. Have fun.